Okay, coming back with compounded interest example problem set number 2. Okay, so we're going to use the same formulas that we did before. Like I said in the previous video, I would copy these problems down beforehand before you watch the video, and leave plenty of space in between so that you can work the problems out. That way you have a good record of it. Okay, first example, if I choose to invest $9,000 compounded interest of 7% over 10 years. You want to know how much will be in the account if it's compounded annually, quarterly, and daily. Okay, so I'm going to be changing the value of your N. Okay, so we're going to use our formula. A is equal to P times 1 plus R over N to the NT power for all of these. Now, like I just said, you're going to be changing your N up. So that's the only thing that's going to be changing. So your principal amount is $9,000. Your rate is 7%. This one's compounded annually. And it's over 10 years. This one's compounded quarterly. So your N is going to be 4. And this one's going to be compounded daily. Okay, so we got to put these in the calculator. So the first one, 0.07 divided by 1 is 1.07, comes out for that parentheses. We're going to raise it to the 10th power because 1 times 10 is 10. We're going to multiply it by 9,000, and you get $17,704.36. Okay. Next one, we're going to do 0.07 divided by 4, add the 1. We're going to go to the 40th power because 10 times 4 is 40. Okay, now we're going to multiply that by 9,000, and you get $18,014.38. Okay, and then our next problem. You're going to do 0.07 divided by 365 plus 1. And you're going to raise it to the 365 times 10 power. And then we're going to multiply by 9,000. So you get $18,122.56. So from this you can tell that if I compound daily, it's going to be resulting in more money than if I compound it annually. Okay, so this kind of stuff matters when you're coming up with investment accounts. Okay, last example. For my retirement, I take $25,000 and invest into an account that earns 4% interest compounded quarterly. How long would it take to retire if I want $1 million in the account? Okay, so we're going to use A is equal to P times 1 plus R over N to the NT power. I want $1 million in the account, and I have $25,000 to start off with. Your interest rate is 4%. It's compounded quarterly. And I want to figure out how many years it's going to take for me to retire. Okay, so like we did earlier, we're going to take the 0.04, divide it by 4, add the 1, so we get 1.01. Okay, from there, you're going to divide both sides by 25,000. You get 40. Okay, now from there to solve for the exponent, we're going to natural log both sides. So we get natural log of 40 is equal to 4t natural log of 1.01. And to solve for t, we're going to divide both sides. So natural log of 40 over 4 natural log of 1.01. So natural log of 40 divided by 4, hit enter, divided by natural log of 1.01, get 92.68 years. So it's going to take a long time for someone to retire. So this might put stuff into perspective. When you go to, start working at a real job with your 401k, how many years am I going to have to work, or how much am I going to have to put away initially to have enough money to where I can retire and be comfortable. Okay, so hopefully this helped you better understand compounded interest, and hopefully you have a good afternoon. Thanks.